tackle any or all of the goals of psychology, we use the scientific method. So let's take a few minutes to review the components of the scientific method. First, we start with observing and usually simultaneously theorizing. Observing just means looking at things, right? Seeing what's in the world, seeing what's happening. Theorizing is kind of the formal way of conceptualizing what we're observing. I might theorize that humans engage in behaviors based on what they've seen in the past. Notice that it's a very broad statement. From there, and after reviewing other theories and research findings, a researcher moves on to formulating a hypothesis. Now, I have written here formulate a testable hypothesis, but a hypothesis should always be testable. So we don't have to have that word there, but I put it there so we can emphasize it. A hypothesis is an expected answer to a research question. It's what we think we will find after we collect and analyze data. A hypothesis is a narrow segment drawn from a theory. So if I theorize that human behaviors are based on what humans have seen, then I might come up with the narrower hypothesis that children who observe sharing behaviors will be more likely to share themselves. And as always, a hypothesis needs to be testable, otherwise it doesn't have much utility for us. If I can't test whether this hypothesis is right or not, there's no way to collect data on it, then we can't move forward with the science. So a good hypothesis is a testable hypothesis. Once we have our hypothesis down, we design a study. That's your research methods aspect. This is where we come up with the way or the process through which we will generate data. One common method that gets used in psychology is the survey design, where we ask people questions about themselves. After we have that design, we can collect data. After data are collected, they can be analyzed. So this brings us into analysis. And the analysis usually involves statistics. And two things can happen here. Either the results fail to support the hypothesis. So we say, hey, I think sharing behavior in children is based on seeing sharing. And if my results do not support that, I would say, okay, I've missed something here. There are other factors that matter for sharing. So if my results do not support my hypothesis, I'm going to modify that hypothesis and test a new version of my hypothesis. I'm going to amend my theory, come up with a new narrow hypothesis from that amended theory, and test that out. We're trying to always get closer and closer to understanding reality. So getting a hypothesis wrong, having data that don't support it, is not detrimental to our field. It helps us understand that that's the wrong turn, that we've missed something else and to go back to the drawing board. The other thing that can happen, which most of us are hoping happens as researchers, is that our results support our hypothesis. So in this example, I find that children who observe sharing behavior are more likely to share. If that's true, at least based on my data, we don't take that as fact. Instead, we take that as supporting the hypothesis, and oftentimes we go back and replicate. That means we repeat the study multiple times to generate a lot of evidence that this thing is true. Now, for my folks who are psych majors, you'll eventually take a Stat 101 class, and you'll learn why we replicate, why it's so important to test things a couple of times at least before we feel quite strong about a conclusion. Now, after either of these has occurred, the theory is modified, right? It could strengthen it when our hypothesis is supported and thus the theory that it was drawn from was supported, or it might require some changes and retesting. A last step of the scientific method that often gets ignored in lectures, I find, is dissemination. So I'm going to mention it here for you guys in case you have not had this one in your lessons about the scientific method. To disseminate means to share findings. So scientists, we don't just hold on to our findings and hoard that information. We actually go through a usually rigorous process of having our work reviewed by other researchers and then published in journals so that it can be shared with the scientific community and ultimately the broader public. So sharing our work is an important part of doing science well that benefits the field and humans overall. One of the main ways we disseminate findings is through research articles. Those are usually about 20 to 30 page papers of original research that appear in journals. You can see those at our library under databases like EBSCOhost. Another way is through textbooks. So textbooks are actually summaries of, usually in psychology, hundreds of different research studies. So even though we might cover a chapter where we talk about what feels like only 6 to maybe 10 big topics, there's probably over 100 different research articles that led up to us having that understanding. So for a quick visual review, I've got a little flowchart for you here. The starting point is making observations and theorizing. Theories are broad. From there, we formulate a testable hypothesis. The hypothesis is the foundation for our research method, or the design of how we will collect data. Once we have that design, we carry it forward and we get our data. We collect our data. Those data are then analyzed, usually statistically, and we hope that the data will support our hypothesis. If so, we often repeat the studies and then modify the theory, either strengthening it in this case, or the results fail to support the hypothesis, we modify the hypothesis and retest and use those findings to modify the broader theory. So you should already be getting the sense that research is fundamental to the field of psychology. So let's dig into that a little bit more. Research can often be categorized as either basic or applied, both of which are highly valuable to our field, but tend to address different goals in psychology. Let's start with basic research. Basic research is conducted to seek new knowledge and explore and advance general scientific understanding. Oftentimes in basic research, we are working on describing the phenomenon. It can also be used to explain or predict. So basic research gives us knowledge about what the phenomenon is, why it might occur, when it might occur, but it's not done to change the phenomenon. A lot of research is basic research, and it has to happen before the applied work can be done well. Applied research, though, goes a step further, and this is more aligned with our fourth goal of influence. This is research that is conducted specifically to solve practical problems and improve the quality of life. So I might do basic research to understand the factors that cause homelessness, but I might do applied research to try to change those factors in a community to reduce the incidence of homelessness. Again, these are a bit hierarchical. Basic research should be done well before applied research is done, but we shouldn't consider applied research the ultimate or only important form of research, because they are each necessary for the field to meet its goals. As noted, research methods refers to the processes through which we gather data. So we're going to briefly go through several of the common research methods, keeping in mind that there's an entire course just on this topic that psych students can take, typically after they finish Psych 1. Let's start with the descriptive methods. One thing that I like a lot about psychology is that a lot of our terminology is very overt. So descriptive methods are methods or processes through which we gather data that help us describe things. Very simple. So descriptive methods meet our first goal of psychology because they are the methods that yield descriptions of behaviors. We'll start with the observational category of descriptive methods. Naturalistic observation refers to when researchers observe and record behavior in its natural setting without influencing or controlling it. Ooh, look, a little typo right there. So for example, if I was doing a study on sharing behavior in children, I might collect data about children at a park or in a classroom. This is a location where those children would naturally be, even if they weren't a part of the study. The benefit of using naturalistic observation is that we're seeing the real world as it is or where it is. So we're not doing as much manipulation to the situation. There's less artificiality to it. The downside to naturalistic observation is that it can be a lot harder to gather data. You are having to wait for the participants to be available. You might spend hours waiting for a behavior to emerge or for a situation to be just right for the behavior to emerge. There can be other outside factors that are affecting that behavior. For example, if I was doing naturalistic observation at a park about children's sharing behavior and only one kid came to the park that day, I'm not going to have any data because who are they going to share with? So naturalistic observation, big benefit, it's more real world applicable. We call this external validity. So they have naturalistic observation has better external validity, but we have less control. So that makes it a little bit more challenging. The other form of observation is laboratory observation. As the name implies, this is done in an artificial setting, also known as a research lab. This is going to have kind of the opposite benefits and limitations to naturalistic. So the key benefit of laboratory design is that we can influence and control the situation. I can create the conditions. For instance, if I want to assess sharing of toys among 5-year-olds, I could set up my research so that 10 5-year-olds are brought by their parents to the lab, that there are toys there that are conducive or not conducive to sharing. I can control the temperature, the time of day we're collecting data, right? I'm not just waiting for it to occur. I'm creating a situation that is optimal for me being able to observe this kind of behavior. The downside to that is it's artificial. When we are controlling or when we are collecting data in the lab, this is not the exact same conditions, not identical to what their real life experiences, the real life situations of these children would be, just by design, right? We are creating the situation in which to collect data rather than assessing the data as it occurs out in its world. So these are the two major observational categories of research methods. The way that the strengths of one tend to be the limitations of the other. Now, some other forms of descriptive research that are not fully observational are the case study and survey research. Let's talk about the case study first. A case refers to a single individual or a single participant or subject in a study. So when we use the case study method, a single person, that doesn't mean romantically single, we mean a person, one person, or a small number of individuals are being studied in great depth. Now, a case study, unlike other methods, has this depth where we may be collecting data about the person over an extended period of time, about lots and lots of different factors. A case study is typically done when there's something that's quite rare, right? Something unusual that we want to know as much as we can about. So, for example, the first time a new psychological disorder is observed, the researcher may wish to do a case study. That's because we want to know as much as we can about this occurrence so we can get to that foundational goal of describing what is this thing that I'm seeing. And we try to collect as much data as possible because we don't know always what is or is not relevant when it's the first occurrence of something. So we don't know what the patterns are going to be because they're not yet established. The reason we collect so much data is so that when a subsequent case comes up, we can look for the similarities and dissimilarities to help us really get through that first goal of description. Now, a completely different kind of research is survey research. And when I say it's completely different, I mean the focus of how many people we study. Because in a case study, we only study an individual or a small number of individuals, typically folks who are connected like a family unit. But in survey research, the big benefit is that we often have sample sizes, that is the number of participants, that are really high. We can collect data from hundreds, sometimes thousands, or even tens of thousands of individuals in a fairly quick amount of time and for little cost relative to using case study or observational methods. So as the name indicates, survey design is where interviews or questionnaires are used to gather information about lots of things. It can be attitudes, beliefs, experiences, behaviors, emotions of a group of people. And typically it's going to be a large group of individuals. If you've ever taken an online survey for a researcher, maybe as a student, you might have been given extra credit in a class or something for doing that. That is part of the survey method. The key benefit of this method is that you can get a lot of information about a lot of different things very quickly and very cheaply from a large group of individuals. The downside to this is that it is subjective. That is, people are telling us their beliefs about themselves. And people are prone to error or bias when they're responding about themselves. One issue we have is something called social desirability. Social desirability refers to us trying to give the answer that we think puts us in the best light or is the one that the individual asking us the question wants to hear. So something that researchers have to look out for when they're using this method is assessing for individuals' honesty, potential bias, and even if they're not aware of it, whether they're responding in the most desirable way rather than the most accurate way. All of the methods that we've discussed so far are in the descriptive realm of research. Sometimes they're even called correlational methods, even though correlation doesn't apply necessarily to all of these. But what these have in common is that they have a major limitation, which is that they cannot be used to generate data that can deduce cause-effect relationships. We can't know from a case study or a survey or observational research if one thing is the cause of another thing. The only method that allows us to do that is something called the experimental method. The most useful research method is the experimental method. That's because it's the only research method that allows us to identify cause-effect relationships between two or more things. Now here I have written variable or condition. A variable just refers to something that we measure that's not always the same, like level of depression, number of children, hours of sleep. Those are all things that we can measure that vary from person to person and from time to time. All the other methods are able to tell us if things are connected or related or tend to trend together, but it can't tell us why. It can't tell us which thing is causing the other, if at all. So for example, I can use a survey to assess whether satisfaction with one's romantic partner is related to stress, but that doesn't tell me whether the stress causes how I feel about the partner, whether how I feel about the partner causes the stress, or whether both of those are impacted by something outside of each of them, right? That they're both caused by some other external factor not already considered. But the experimental method has certain parameters in place that allow us to situate one thing as the cause and one thing as the effect. So the experimental method has many different ways data can be collected. What differentiates it from the other methods that we've already discussed is that it has parameters in place that allow us to situate one variable, that's a thing that we measure, as the independent variable or cause, and another as the dependent variable or effected. So as noted, an independent variable, also referred to as an IV, is the theoretical cause in a cause-effect relationship. The dependent variable, or DV, is the theoretical effected in that cause-effect relationship. Let's walk through an example to help us understand the two. Suppose that we hypothesize that having a study guide will improve exam scores. We have an independent variable here, which is the study guide. We believe that is the cause here. And the exam scores are the dependent variable because we are situating them as effected by the study guide itself. There are different ways an experimental method can be used, but a common version is to use the experimental and control group version. Here you have one group, the experimental group, who is exposed to the independent variable, and a control group or a baseline comparison group that has the IV withheld. So for the hypothesis that study guides lead to higher exam scores, the experimental group would receive the study guides, and the control group would not. Let's take a second example. Suppose that I hypothesize that my new vaccine will reduce risk of illness. There, the independent variable is the vaccine, and the dependent variable is the illness, right? The rate of illness. The experimental group in this case would be given the vaccine, and the control group would get no vaccine. And the two groups would be monitored over time to see the level of illness, so it can be compared between the two groups. Let's try one more to see if you can figure out the pieces yourself. Suppose that we hypothesize that exercise reduces anxiety. Pause here and think about what the independent variable is, what the dependent variable is, what would happen with the experimental group, and what would happen with the control group. Then hit play and I'll go through the answers. In this example, exercise would be the independent variable or cause, and anxiety would be the dependent variable or affected. The experimental group would have exercise added to their routine, and the control group would not be exercising as part of their routine. After a set amount of time has passed, the two groups would have their anxiety measured and compared. Before we finish our brief review of the scientific method and research methods as they relate to psychology, I want to take note of the importance of doing our work ethically. There are two major arms to the field of psychology: the research side, which has been the focus of this lecture, and the clinical or therapeutic side, which we'll learn more about later this semester. But it's important that our work be done ethically in both of these realms and, frankly, throughout all parts of our career or our time in the field of psychology. A researcher must use good methods, but they also must ensure that all participants have consented to be involved in the research, that their responses or efforts in that research will be anonymous unless otherwise stated, and the research is conducted in a way that doesn't do harm or undue harm to those individuals. Now, some harm or discomfort can occur in research, but it must be disclosed to the participants, and other factors must be in place before that research can progress. Research has to go through something known as a Human Subjects Internal Review Board, or IRB. This is a group that oversees the plan or methods as stated for data collection. They pay special attention to things like anonymity, confidentiality, consent, and reduced risk of harm to individuals. In order for a researcher to be allowed to collect data at most institutions, an IRB has to have reviewed and approved that work. And depending on the type of research, timely reports may need to be given to the IRB showing that these criteria are being met. Another issue, unfortunately, that we have to deal with in research is falsified research. Thankfully, this is quite rare, but when it does occur, it is detrimental to the field. There have been occasions where researchers have made up their research or published work with results that were not actually supported by the data in front of them. These rare cases reduce confidence in the field and can lead many researchers astray. If you were to publish a fake paper, right, showing that your hypothesis was right, say about a therapy being good at reducing anxiety when it wasn't, then you could have hundreds or potentially tens of thousands of clients who need good therapy receiving a form that doesn't work based on fake results done by an unethical researcher. This is part of why you'll see throughout our course, I'm going to be very focused on ensuring that you're doing your work honestly, that you're not using AI to complete your work, that you're not turning in someone else's work. So always contact me if you need help understanding a concept, because it is really important to our field that from the first days that we engage with the work, that we do so honestly and ethically. So it is necessary as a student or a practitioner in the field of psychology to adopt an ethical mindset. There are several ways this can come about in clinical work. I'll go into the details about those towards the end of our semester when we do our lecture on therapies and careers in psych. But to give you just a couple of ideas here, a clinician should be using methods that have evidence behind them or at least sound theory to support them. And they need to set strong relationship boundaries with clients due to the hierarchical and delicate nature of doing clinical work. For example, clinicians are prohibited from engaging in romantic and sexual relationships with their clients for reasons that should be obvious, but if not, we will go into more detail about later this semester.